Okay, here we go. So this time we're going to simplify square roots and cube roots, and they're not actually perfect cubes. And you're not allowed to just like put it in the calculator and turn it into a decimal. You got to actually use it, simplify it in a different way. So you remember from yesterday that if you don't know your perfect squares and perfect cubes, you should know how to generate a list of them, so you could at least check against the list. You remember how to do that? Go to y equals, right, on the first line. Let's say put x squared, and the second line do x to the third. You know how do you do x to the third power?
You press X and then a little hat. And
then... Yeah, x hat 3, right? So if you want to do any exponent other than 2, that's how you have to do it. If you're going to do x squared, you should use the x squared key. I mean, it does work better. Hunter, take off the... All right. So that is a list which we will not actually be using a lot exactly like that today. So let's say we have to find the square root of, we want to simplify the square root of 60. Now, do you remember doing any of this before? Did anybody remember doing factor trees?
yeah.
Factor trees. So with factor trees, you would take that 60 and go, let's see, it's even, so 2 times 30 is 60. Okay, 30 is even, so 2 times 15 is 30. 15 is 3 times 5, so 2 times 2 times 3 times 5. And since the 2 is under there twice, you take it out once. Does anybody remember doing that kind of thing? Okay, well, I'm not going to do that. I don't like doing that. Okay? So instead, the way I like to think of it is like this. First, you look at the number which is underneath the radical. Is it a perfect square? If it's a perfect square, then it shows up in your list and you're done, right? You just say whatever this number is, that's the square root. If it's not a perfect square, then you have to see, does it have any factors that are perfect squares? So let's see. We're going to start at 60, and then what's the first perfect square which is less than 60?
49.
So divide 60 by 49. What do you get?
60 over 60.
Okay. Well, right? Do it. Let's do it. Just okay, clear. So if I do my 60, I'm having some issues with this today, for sure. Yeah, okay, so I'm going to leave it there. 60 divided by 49. Right? And I get 1.22. Bottom line, it's not a decimal. Right? If 49 is a factor of 60, then it should not be a decimal. So let's try the next biggest perfect square. Right? What's 60 divided by 36? Somebody do that. 1.6 repeating? Okay, sounds right. How about 60 divided by 25? 2.4? 2.4? Okay, how about 60 divided by 16? 60 divided by 16? 3 points. I think Adam had it, and I didn't hear it. Okay, the next one, 16 divided by... what do I have? It should say 60. 60 divided by 9. 60 divided by 9. 6 point something, right? And what is 60 divided by 4? That's the 15. So you keep dividing by perfect squares until you find the perfect square, which happens to be a factor. So you find the first non-decimal. And let me see if I can get this. So since I found the 4 is a factor, the square root of 60 is the square root of 4 times the square root of 15. And the square root of 4, actually we know, that's 2. So 2 times the square root of 15. Done. That's what we're being asked to do to simplify square roots. Find the factors of 60 that are perfect squares so that you can simplify something. You can't simplify everything. It's not a perfect square. Good question? What's that? That's not what we're doing here. Okay. I mean, does it have a decimal value? It does. But when you look on tests, I mean, that's not going to be one of the options. Yeah. Okay. Okay. So quiet, please. So this kind of depends on a property, which we call a product property of radicals, which is that the radical of a product, 4 times 15, equals the product of the radicals. If 4 times 15 is 60, then I should be able to split up the radicals into two parts. Make one part the square root of 4 and the other the square root of 15. Right? Those are equal. Now, what is the square root of 4? 2. So you replace the square root of 4 with a 2. And you're done. What's that? How do you know 4 times 15 is 60? How do you know that 4 times 15 is 60? Yes, 4 times 15 is 60. Okay. I'm just simplifying this line. Do you see where the square root of 60 is square root of 4 times square root of 15? I can split those up. I can always take the factors of a number and split up radicals into multiple radicals. Now, what is this? I'm just rewriting this line here. Right, because what is the square root of 4? 2. So I replaced it with a 2. Right? So we'll do some more and you'll see. What's that? If it was the square root of 5, you couldn't do it because it's not a perfect square. The whole point is you're trying to find factors of that number which are perfect squares. Hunter. Okay. Take the square root of 4. What's the square root of 4? So I'm just replacing the square root of 4 with a 2 because they're equal. Yeah. Okay. Do what now? Is 15 a perfect square? What are the factors of 15? Basically 3 and 5, right? And so neither one of them are perfect squares, so actually you can't go any simpler on the square root of 15. Yeah, so this is the answer. 2 times the square root of 15. That is the simplified square root. Yeah. I mean, put the square root of 60 in the calculator. What do you get? What is the decimal value? Okay, now do this. 2 times the square root of 15. What is 2 times the square root of 15? It's the same thing, yeah. I mean, so those are equal. You can confirm that. You know, the problem is that when this is like a 3-step process. Right? Yesterday we did square roots and cube roots of numbers that were perfect squares and perfect cubes. Today we're going to do the square roots and cube roots of numbers that are not perfect squares and perfect cubes. Then we've got to put it all together because ultimately we're trying to simplify radicals that have variable expressions underneath. One part of that might be a number like this that we've got to simplify like this. And then we're going to have to learn, okay, then what do we do with the variables that are under? So just like trying to take one step at a time. You know, is it true that the decimal value of these are true? I mean, they have to be. If we did everything right, it has to be true. Okay, so now, here's an alternate way to do this, which I think you might find easier. Okay, so since we're trying to find the square root of 60, go to the y equals in your calculator. On the first line, put x squared. Right? We did this yesterday to say this is your perfect squares if you need them. Okay. So first line is x squared. The next line is 60, the number we're trying to simplify, divided by x squared. Okay. Once you've got that in there, go to the table of values, right? Second graph. Now notice what we've got here, right? In this column, we've got all the perfect squares. In this column, we've got what you get if you divide 60 by all the perfect squares. Does everybody have this screen?
Yes.
Okay. If you need help with that, let us know. We all got to get to this point right here where you've got this on your table of values, right? Let's see. You're good. Actually, y equals x squared. You're good. You get it? Yeah, I mean, if you got x squared, yep. If you got the 60, I'm going to show you in a minute. That is the next slide. Okay. That is good. That was good. You do. Okay. Yeah. Adam, you good? Everybody over here got it? Lisa? Okay. No. You put x2. You didn't put x squared. Right? So you got to go there. No, you didn't. Delete.
Oh,
X squared. Right? Okay. So now, this is the way you go through that list now to solve this. First, go down this list of numbers here until you exceed this 60, right? So the numbers, you can see 60 is not in this list, so it's not a perfect square, right? But 60 would have been right here. So go down that far and then jump over to the other list, right? And now go back up until you find the first non-decimal. So how far do we have to go? Decimal, 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 decimal. There's a non-decimal 15. So that's telling you that 4 times 15 is 60, and the square root of 4 is 2. Done, right? So once you find that first non-decimal, that's telling you the factors of 60 that include a perfect square, and you know the square root of that number is right there. Okay? So here we go. Again, this is a product property for radicals. Square root of 60 is the square root of 4 times 15. I didn't split them up into two radicals this time, but the square root of 4 is 2. Okay, try this one more time. Try to do the same thing with 72, right? So put in on y1, this thing is not working. Right? On y1, we're going to put x squared. And on y2, you're going to put 72 divided by x squared. Sorry. This thing's just not working anymore. Okay? Let me write that over here. Square root of 72. And now I can bring my calculator back up. Okay, did everybody get that? X squared, 72 divided by x squared. Go to the table of values. Right? Does everybody have lists that look something like this? Okay, so we want to scroll down this list right here until you get to 72. And if 72 is not in the list, keep going. So 36, 49, 64, 81. It jumped right over 72. So at that point, 72 would have been right there. So jump over to that list and go up until you find the first non-decimal, which is 2. So actually, the square root of 72 is the square root of 36 times the square root of 2. And what is the square root of 36? 6. Okay. So I'm looking at that right there on the list. It looks like 72 equals 36 times 2. So the square root of 72 should equal the square root of 36 times the square root of 2. And the square root of 36 is 6. So there you go. Well, that's why I got to practice it. So here's the thing. If you look at 72, if I just said, what are the factors of 72 that are perfect squares? There's actually more than just 36. How about 4? How about 9? Right? But you want to find the biggest perfect square, which is a factor of 72. That's why if you like go down this list and then you jump over and go that direction, so that'll get the biggest factor, which is a perfect square. Otherwise, you go up here, look at 8 times 9, that's in there. You could have said 3 times the square root of 8, but the square root of 8 is not simplified, because that's 4 times 2. You know what I mean? So that's why go down this list until you get where your number should have been, then jump over there, and what you're doing is dividing your number by all the perfect squares until you find the biggest perfect square, which is a factor. What's that? I kind of found it on my own. I mean, I made this up last year. After I taught it in class, I kind of thought of this as being an easier way to put it together. But okay. So now we're going to jump. Okay. Now we're going to go to the cubes. And I know that we need more practices with this, but after we spend 5 or 10 minutes on the cubes, then you're going to get a worksheet and we're going to practice and we're going to be here and we can help you. Okay. So let's say that I wanted to find if I wanted to simplify the cube root of 162, right? So the first thing I need to say, is it a perfect cube? And I look in my list of perfect cubes, and actually that doesn't, yeah. Oh, remember we had the list of the squares and the cubes. I look down in this list, and 162 is not in the list, right? So then I want to ask myself, okay, are there any factors of 162 which are perfect cubes? So let's see, let's just start dividing our number by all the perfect cubes until we find one that divides evenly into it. So that's what I'm doing here. 162 divided by 125. Somebody put that in their calculator. What do you got? 1 point. What do you got? 1.2. Okay, that's good. Okay, try one. Oh, sorry, that was wrong. 1.2 there, approximately. What is 162 divided by 64? Okay, it's about 2.5. Okay, what about 162 divided by 27? It's actually exactly 6. So that is where we want to go with that. We can say that 162 is 27 times 6, and the cube root of 27 is 3. Right, now this is more the long way of doing this. I'm going to show you next that we have the same kind of process that we did with the square root. Yes. Yes. So, what we've done here is we found the biggest factor of 162, which is a perfect cube. And then we simplified that part of it. We can't simplify the whole thing because it's not a perfect cube. So yes, if you want to do this like we did the other, then we're going to do this. On y1, put x to the third. On y2, put 162 divided by x to the third. Yeah, Connor? Yeah, well, why would it be an error right here? Because you're dividing by 0. Yeah, you're dividing by 0, so that should be an error. Okay, so everybody should get this on the screen, right? On your calculator screen. You got, this is the perfect cube. This is our number, 162 divided by all the perfect cubes. And then we're going to go through the same kind of process. Right, you're going to go down this list until where you see 162 should have been, right? That would have been in between 125 and 216. And then you're going to jump over to this list and go up until you find the first non-decimal. So it's right there, it's 6. So 27 times 6 is how we want to split it up. Right? 27 times 6. So the cube root of 162 is the cube root of 27 times 6, and the cube root of 27 we can simplify. And that's actually right there in that column.
So all the Y ones, all those ones will be able to be simplified.
Yeah, these are all perfect cubes. If you get that number, then you're done right away. If you get the cube root of 216, you're just going to say 6. Right? What's that? You put on the first line x to the third. Remember? Like that, Lily. Lily, see? First line, x to the third. Second line, 162 divided by x to the third. All right, so try this one. See if you could use that same process. Okay, you're going to have to, on the first line, you still want x to the third. On the second line, you want 80 divided by x to the third. See if you can figure out how it breaks down. You do it? Let's see. There's that in there. 80 divided by x to the third. So table value. So you go down until you find 80, which is going to be the right one. 8 times 10. There you go. Hunter, you working it? Go to y equals. Okay, you got to take it out. You've been playing along here, right? X to the third. X is button right there. Hat. 3. Okay, now enter. Now do 80 divided by x to the third. Did you get it? Right? How did you split it up? Okay, well, so it's split. What were the two numbers? 8 and 10. So which one of those is a perfect cube? And what is the perfect cube of 8? 2. So you simplify. Excuse me. You got it in there? So you go down, you don't find 80, so you jump over here and you go until you find the first non-decimal, which is 8 times 10. And the cube root of 8 is 2. That is right. Yeah. My calculator's not. I didn't put it in yet. Okay, you got it, right? So you go down this list, you don't see 80, so you come over here, and you go up until you find a non-decimal. There you go, 10. So 8 times 10. And then you take the cube root of 8 is 2. Write down 80, go like this. 80 equals 8 times 10. 8 times 10. Okay? And now write the cube root of 80. You could write it right over the top. Equal. Put a little 3 there. The cube root of 8 times the cube root of 10. The cube root of 8. Put a little 3 there. And the cube root of 10. Now what is the cube root of 8? The cube root of 8 is, so we'll place it, equals 2 times the cube root of 10. Julian? Okay, I'm going to finish this one up here because a lot of the same questions. Everybody's got to, quiet please, listen up. So let me do it up here, clear. X to the third and clear. 80 divided by x to the third. Right, now I go to the table of values and I scroll down. In my x to the third column, I don't see 80, right? It goes from 64 to 125. So then I jump over to the second column and I look for the first non-decimal as I go up. And it is 10, right? So that tells you that you could split this up 8 times 10. So 80 equals 8 times 10. The cubed root of 80 should be the cubed root of 8 times the cubed root of 10. And what is the cubed root of 8? Right? That's also in your calculator, right? Just go into the first column. The cubed root of 8 is 2. So this is 2 times the cubed root of 10. Again, if you want to confirm it, how do you get what? Do you have that in your calculator? Okay.
Where do I go to?
So you go over here, you go to 80, it's not there. So you jump into there and you scroll up until you find the first non-decimal, 10. 8 times 10. Okay? Okay. So the best thing we can do with this now is just to practice it. So we're going to hand out a worksheet to start working on this. You know, you'll get it. Just takes a couple times.